Hey students, and welcome back to another one of these little tutorial videos that as you work your way through the holiday homework. I wanted to spend a little bit of time talking to you about something that's coming up in this document now, and you're going to hear a lot about over the next number of weeks, which is ATP, adenosine triphosphate. So as you look through the textbook, it's one of the first bold words that you come across, adenosine triphosphate. And you'll notice that throughout this entire chapter, adenosine triphosphate is one of the most critical elements. There's a few notes that I want to talk to you about, and I just want to make sure that everyone understands what adenosine triphosphate is, because it can be quite a challenging piece of information here. I feel like this first diagram can get overly confusing if you haven't looked ahead at one of the diagrams later on. So a few pages in advance from this point, so we're now on page 112 of the textbook, I've zoomed right in on what an adenosine triphosphate looks like within the human body. And you'll notice here that this energy carrying molecule, and we'll talk about a molecule in a moment, is 1 part adenosine, which as you can see here, is connected to 3 parts of phosphate. We've delved right in, we've got really deep, we're trying to find out what does this all mean. We want to talk about interplay, we want to go on to the second half of this diagram about breaking down adenosine triphosphate, and I've created a very quick set of notes to refer to. Adenosine triphosphate, it is an energy carrying molecule that is found in our body's muscles. Muscles are cells, and as the muscles are moving, the energy that is carried within the ATP is what actually makes that muscle contract. So what is a molecule? We've used that word a couple of times now. It's a group of 2 or more atoms, which are the smallest unit that all matter can be identified in the world. So we're zooming right in deep to a microscopic level inside the muscle and grouping these molecules together. It's really important to note right now that ATP is the only item, the only molecule found inside the human body that is able to make muscles move. We talk about carbs giving us energy, sugars, different foods. We're going to get to all that. However, ATP is the only thing that is able to make muscles move. ATP is made within the mitochondria, which is inside a muscle's cell. So it's made there and it's stored in that muscle, waiting for a message from the brain to say, hey muscle, contract. And when that muscle is able to contract, the energy is found inside this energy carrying molecule. So we have our adenosine triphosphate here. And I'm just going to draw in a couple of arrows for you. We have our adenosine pretty clearly labeled. And now what we need to do is we need to see these 3 P's are 3 separate phosphates. And so 1 part adenosine, 3 parts phosphate is how we get the name adenosine triphosphate. But what's most important is not the adenosine, it's not any of the 3 phosphates. It's actually the lines that come in between the 3 phosphates, because these lines here are high energy bonds. Bonds meaning being held together, high energy meaning this is where the energy comes from to be able to move a muscle. I'll create another video to show you how that works using the whiteboard behind me.